Let's see. All right. So, hi, my name's Marc Goodner. I'm here from Microsoft to talk about cross-platform tools and cross-platform C++ code and how you can use tools to help you develop cross-platform C++ easier. I'm on the C++ team at Microsoft. Our team owns the implementation in Visual Studio, of course, for all the support for C++. We also own the MSVC compiler and the C++ extension for Visual Studio Code. Personally, I have spent a lot of time on the Linux support in Visual Studio Code, or I'm sorry, in Visual Studio. And I've also worked on Azure Sphere, which is our secure IoT platform, which is a microcontroller, a cloud service, and an operating system. But I'm not going to talk about that today. But if you are an embedded developer, I'd love to chat with you, because that's an area I really think that I'd like to do a lot more for Visual Studio and VS Code. Thank you to the sponsors for this conference. This is great. This is my first time in Milan, and I'm very happy to have the opportunity. So Marco, thank you for putting this together. This has been really great. And this morning I reorganized my slides. I have way more content than will fit. So I changed up the order to try and put the more exciting stuff at the beginning. So we'll start with talking about VS Code. So Visual Studio Code's our free open source editor. It's been getting top ranks on Stack Overflow and other developer surveys as one of the most used code editors today. And the C++ extension that our team works on enables IntelliSense and debugging and code browsing. And it's pretty easy to use. But one of the things we've been working on, in particular with the VS Code extension for C++, is to help new users get started more quickly. So some of the more recent features that we've added are more focused on getting people running up and quickly. And I usually have a demo on that, but let's talk about something a little more exciting, which is remote development with VS Code. So how many of you are aware of this feature in VS Code, that VS Code now can run locally on your machine, but the back end of it can run remotely on another system? Few people. Okay. So I'm going to show this. What this allows you to do is you can develop on your host operating system, but you can connect to a back-end system, to a container or to a VM or a remote system, and the back end of VS Code runs there, so you get the IntelliSense for that remote system instead of for your local system, which is pretty cool. And you can actually debug and build and everything there, just as you'd expect. And the way that this works is basically the host environment for all of the UI controls and everything runs on your local operating system, and there's a new backend that runs on the remote system that the front end now talks to. So all of the stuff that's doing all the work of the IntelliSense and all of this stuff and building and debugging is all running on that remote backend system. So let's just go ahead and pop out to a demo for this. And I will try and talk about other tools as we go to highlight some other things, and this always gets me with PowerPoint. I need to stop presenting. There we go. All right. So one of the first things I want to show you, if you're on Windows, this is a VM, but is HyperV. How many of you are aware of this little quick create? In HyperV, there's this quick create button. Has anybody tried this? Does anybody know what that does? This is pretty cool. Let's get out of there. So if I click quick create, what this is going to do, it's going to pull down some options to install operating systems from, I believe, from a cloud service. And there should be some Windows options there. Hopefully my internet connection is working. There we go. So you can see that there's some options here for Windows 10 development if you want to create a Windows 10 VM. But you've also got some Ubuntu VMs here. And the Ubuntu VM that I'm using was created with this quick create. Now, why would you want to use this quick create? The reason you want to use this quick create is the quick create actually sets up the Ubuntu VM so that copy and paste works. So you can copy and paste from your host OS to the VM. And I know that that's like a little thing, but this was so hard to configure manually with Linux VMs. This will set that up for you, and some other things like sets up for scaling so that you can set up the window in whatever size and you're not stuck. It's pretty great. But at any rate, let's pop over to VS Code. So this capability for the remote is only available in the Insiders Edition, which should have started. Oops. There we go. Now I've started multiple instances. So VS Code has a shipping schedule where VS Code ships on a roughly monthly basis for their release versions of VS Code. The Insiders builds are basically like almost the dailies. You get an update almost daily for the Insider build. So this is off-road here. But if I come over here, you can see I actually opened this project before, and so we're going to open this little quick sample here for a box console sample. And you can see it says SSH machine because that's my VM machine name is machine. And you can see it's the path to my home directory there. So go ahead and open that. Okay. There we go. So what this is doing now, it's actually connecting to the remote, and all of the code that we're going to open is actually on the remote. I'm not on my local machine right now. This is opening code that's in the VM. And this works with containers as well, or actual physical hardware that's remote. It does use SSH, so you need an open SSH connection to use it. There is nothing like lag when you're on stage. Come on. But so it's pulling down, it's opening my environment eventually. What else can I see? I should have saved showing you the VM while that was going on. Okay. That's not going well. Let's see. Let's just stop that and try again. Let's see, retry attempts. Oh, that's just awesome. Let's change tactics. I'm just going to let that sit there, and I'll show you something else. So the other thing I was going to show you was VS Live Share. So let's open up a project in our Linux environment. How many of you are aware of VS Live Share? Do you know what this is? VS Live Share, yeah, a couple people, okay. VS Live Share is something where you can actually share what you're doing with somebody else on their system. And this works across, so you can take and say, I want to look at this code base with one of my colleagues, and you can share a link that will then open that code base either in VS Code or in Visual Studio. You can use whichever your preferred editor is across the IDEs. So I'll open up this environment here for OpenSCAD. How many people know what OpenSCAD is? A couple? Yeah. There's never as many 3D printer people here as I think. So OpenSCAD is an interesting program that is it's a program that lets you create 3D geometric models with scripting. And it's very popular within the 3D printing community. But it's a quite old program. It uses Qt, and it uses an environment called MXE, which is a cross-compiling environment that uses MinGW so that you can build Windows binaries on Linux. So you can build this on Windows, but it's very difficult because you have to set up a MinGW environment on Windows. It's actually easier to build the Windows binaries for this on Linux. But the thing is, the initial setup is about a day. It takes about a day to build, at least on my hardware the first time I did this. And one of the things I want to share here that's interesting, when you look at open source projects like OpenSCAD, one of the things I find when I'm trying to set up demos like this and I want to highlight debugging or something like that, I can't ever find the instructions on how to get debug symbols. And the thing that I finally realized was that it was just a dirty hack. This is a Cmake project, so it's Qt, you run Cmake and Cmake, but ultimately there's some make files. So the thing that I finally figured out was just come in here and modify the make file with -G. And then I get my debug symbols. It's kind of one of those just really dumb things, but it's really helpful because I never find documentation on how to do this. But the premise of this would be that I'm sitting here and I'm working on, something, and I'm on Linux. This is a cross-platform application. Something's happening with Windows. I don't know what's going on. I want to talk to a colleague who is more familiar with Windows. And so what I can do is this icon here. This is an extension. This extension works in the production versions of Visual Studio and VS Code, so this is not a requirement for the insider build. But I can start live share, and what I can do is say start a collaboration session. You can also see based on this dialog here that this is quite a large project. But so now it's taken and copied a link to the clipboard. And so now I can send that link via chat or an email to somebody else who wants to join this session. You can have multiple people join this session. There's a chat here where you can chat with each other about the code. There's actually even some Skype or voice capabilities within this tool. But what I'm going to do is come over to Windows and start my browser and paste that link in. I didn't have to do anything because that just came from Linux, from my VM there. But now I'm going to open the app, and I'm going to choose Visual Studio. And so what Visual Studio is going to do is now going to load that entire workspace from this Linux machine that's running in VS Code. And I'm going to be able to see all of the source code, and we're going to be able to share a debug session and everything across these two instances. So this is building up the context here, pulling down files. You can see up here in the corner, up there in the corner it says joining, so that's kind of there's a very subtle UI for this in Visual Studio. There we go, so here comes all the files. This is quite a big project. Come on, I don't have that much banter. So here we are. So now we're seeing, it's opened the file for, what happened to Visual Studio? Okay, that's just great. The demo gods are not with me today. It's because I practiced, I'm sure. Well, while that's coming back, let's see if this opened. I am not having a good network connectivity day. It worked in the other room, I swear. So actually, while the other one is popping back up, I'm going to go ahead and come back to this demo since this is ready to go. And let's make this bigger. Oh wait, yeah. So this is just a really simple little program here, just a really simple little demo. And what we're back in VS Code now, and this is talking to the remote Linux machine. So this isn't on my local host. This is the VS Code remote session. And you can see here, one of the things we've added recently is this type here, we've actually got help for it. And so it's like, where is this coming from? And if I go to the definition for this, it's actually coming from the code comment on the class, or on the struct. So this is kind of one of the examples of things we've been doing to improve this for new users. Or just kind of help promote good coding practices. If I set a breakpoint, now one of the other things you'll notice when I do this, if I go to F5, so when I F5, it asks me what type of application am I using, and so I'm going to say C++. And now it says I've got a new option here. This didn't used to be here. You used to have to configure like a build environment. But for new users, students, and people like that, particularly who are new with C++, don't understand makefiles and setting up, especially Cmake. So now I can actually say I can choose to use G++ to build and debug the active file. And so that's just going to go ahead and set everything up I need for that and run that. And so there we are. We're actually debugging this. I didn't have to set up a makefile or anything. I just hit F5, and now I can actually build and debug this single file. So that's pretty cool. Now, one of the other things that we've done to make it easier to use VS Code for new people is we've made it easier. So I want to add maybe one of my own files here, and I want to add, actually, since the demo gods aren't with me, I'll look here, and what I will do is I will go SSH. This is WSL. How many people are aware of WSL? Windows Subsystem for Linux? Really, not very many people. Okay, so Windows Subsystem for Linux is a Linux environment that runs in Windows. You install this from the Windows Store, and this gives you a complete Linux environment that runs on Windows. So you can use Bash. You can choose even your flavor of Linux to run here. So this isn't a VM. This is actually running in a more optimized process. But so now I don't have to do something weird and use SSH from PowerShell or something. I can actually just use Bash directly and SSH here from this console. So I have SSH into my remote machine that this VS Code system, the VS Code is using here. And you can see that I have, so I've got source, shipping, and then I've got a package.hpp there. So what I can do is say shipping, package.hpp. And of course, this isn't working because I haven't configured VS Code to tell it where my includes are. But you can see here, I actually have a light bulb that's telling me, hey, I can help you out here. And so what VS Code has figured out is that there's actually a source directory in my home directory that has what it looks like I just typed. And so this is offering to add it to my, my preferences so that I can actually get IntelliSense for my local folders. And so I can just click that, and then that's going to create the CPP properties JSON file and add that setting there for me, making this a whole lot easier for people who aren't familiar with like the config files in VS Code, for example. And the other thing we've done is you see this file, this has popped up. We actually now have a graphical version of the CPP properties.json so that you can see what the documentation for all of the properties are for configuring your project, which is pretty, you can still get to the JSON if you need to. And the other thing that we've done is if I say include catch, so they see it's picked up catch right there. So what's going on here is it's actually discovered my libraries on the Linux system because I'm using vcpackage. So vcpackage is our cross-platform library manager. And so VS Code is now aware of vcpackage. And if I'm using vcpackage, it finds where vcpackage is. And now I have access to all of my libraries from vcpackage without having to do any extra configuration. It just works. So that's VS Code remote. And let's come back here and see if this is ready. So we're back here again. Now we're doing the live share again. And what I'm going to do is go back to my VS Code session here, get a little bit more screen real estate. And I want to talk to my colleague about some behavior that I'm seeing that I don't understand. And so I'm just going to go ahead and click debug. And this is going to launch. Now it's going to launch OpenSCAD. So here we go. So you can see GDB. GDB's running in the background there. And now I can, this is the OpenSCAD window. And I can pick their logo and open that example. And so let's say that the problem I was having was something around, you know, opening a new file. And so when I click that, what's going to happen is it should get to my breakpoint, is what should happen. But it didn't. Great. I don't remember telling this to get rid of my breakpoints. That's still not doing it. Interesting.
There was a message about breakpoint when you started.
A what?
When you started the application in the album,
Yeah.
it was mentioning something about breakpoints.
Oh, was it? Let's see. That message usually persists. That's the error message I'm accustomed to seeing there, but we can. Let's close that one. Let's try again. Yeah, so GDB failed to set something, didn't it? Yeah, that was too fast for me to catch. Yeah, so I missed my breakpoint. Let's cheat. So, oh wait, what? Oh, I see. There we go. Now we're back into our code. All right. Let's get rid of that. I just hit pause, and it paused inside of a Linux call, which I didn't have symbols for, which was what that error message was. So I just stepped a couple times to get back into my code, because the details of this aren't what's actually important. What we actually want to see is Visual Studio here. So you can see Visual Studio is actually in debug mode now. And why do I not have my step options? This is not going great today. Let's step over that. Oh, there we go. Exec next. Cannot found bounds of current function. I have not ever hit that with this particular demo before, so that's just awesome. Let's just go back to Visual Studio anyway. One of the things I wanted to highlight here was that as you're sharing a session like this, had I not done whatever I did that broke debugging, probably not restarted my VM after closing my laptop, but you can actually browse the entire project space on your own, so you're not limited to the viewpoint of your remote participant who started the session. You can actually come in and you can look at other things. So while maybe somebody's droning on about what they think the problem is, and your intuition is taking you in a different direction, you can actually follow that. And then one of the things you can do is you can come up here, and when you find what you're looking for, one of the things you can do is you can hit Focus Participants. And so what this is going to do when I hit Focus Participants, it's going to force everybody to look at the same file. So you see Live Share says Focus Request Sent. And so if I come back over here, this is just not going, oh, this is not going great today. I apologize. Yeah, but you can see that it did find, now we're on boostutils.h, which I did not open in VS Code. That got opened because of that focus request that came from Visual Studio, which was this boostutils.h that I opened. So this gives you a lot of power to collaborate interactively with people across different operating systems, across VS and across VS Code. You can use the environment that you prefer from a host operating system and from your tools, and you can still collaborate with other people, which is pretty cool. Now, finally, when I'm done collaborating, once my Windows colleague has pointed something out to me and I don't want to talk to them anymore, I can say stop collaborating. And so what that's going to do, that's going to end the VS Code live share session, and you can see live share is giving me an error message that the collaboration session is over, and I say okay, and like that, poof, everything is gone. I don't have any of that. None of that's actually on my system. So none of that's persisted on the session. That code is only on the session of the person who started the live share. Now, one other thing that's related to this that I want to show you is attached to process. So I think this might be a little bit of a more common scenario. So yeah, don't save. I don't know what I did. Let's close that. And let's come over here. And what we're going to do is we're going to go into repos and OpenSCAD. And so you can see there's the OpenSCAD binary. And what I'm going to do is I'm just going to start that OpenSCAD binary directly instead of from VS Code. So now this is just running, and I can start one of these little scripts. And now I've got a process that's running. So let me ask a question. How many people here actually develop cross-platform code? You're targeting more than one platform with your code, like Windows, Linux. Okay, so a lot of people. How many of you, before you check in, actually test on all the platforms that you're targeting? A lot less. A lot less. And are you sure? The guy in the back in the blue shirt, are you sure you actually do that? Yeah. So what happens, this is not uncommon. I find that when we talk to people who are doing cross-platform development, a lot of people, they work on the platform that they prefer, or maybe the primary platform, and it's the build system that takes care of actually building for multiple platforms, and you kind of wait for an integration report or something to tell you whether or not there were any problems. And so you don't find out until later. And then sometimes maybe it's something simple, but sometimes if it's something hard and you actually need to debug, now you're in trouble because it's on a system you're not familiar with. One of the complaints I get from Windows developers in particular is that they don't know GDB. And so if they have to debug on a Linux system and they're a Windows first person, they don't know how to use GDB. But Visual Studio actually lets you connect to remote systems. So this is, if I could spell, what I want to show you is, so this is the quick launch in Visual Studio. That quick launch up there, you can search and it will find, you can just start typing and it will find menu commands or other tool windows and stuff like that. It's a great way to not poke around through tools options in the menus. You can just type what you're looking for and it'll bring it up for you there. And so in this case, what I'm looking for is the connection manager that I want to show you. This connection manager is in Visual Studio. This enables Visual Studio to use SSH to talk to a remote system. And you can see here that I have one system set up, which is this local IP address. Oops. Oh, oops. So I've got this local IP address set up. If anybody else does demos, talk to me about how to set up a VM so that you have internet connectivity and a stable IP. Multiple network interfaces is the answer. But at any rate, I've made my connection to this, and you'll see this other window here, which is remote header cache. And so when you establish an SSH connection to a remote Linux machine with Visual Studio, one of the first things we do is we query the compiler to find out where all of its includes are and what version of the compiler it is. So we pull down a whole bunch of information, including all of the headers on that system, to your local environment, and that way when you select that machine that you're targeting, you get IntelliSense specific to that machine. So when you have multiple Linux systems, you can have IntelliSense specific to each one of the connections that you're using. And you can see here that there's options to actually take a look at the file system on what's there. And you can update it. If you've got a space issue, you can delete your cache. So that popped open Windows Explorer in the background. So you can see here, it's my home directory. And we also find VC package, so if you're using VC package on Linux, we'll find that location, pull those headers down. So now what I can do that I have that connection, I was saying that you're in a situation where you want to debug a problem with the Linux system that you weren't ready for, you weren't expecting, but I can just go attach to process, and there's this dialog here for attach to process for SSH. So I can pick SSH, and then I can pick the remote machine name that I'm interested in there. And, oops, sorry. So I can pick that, and now I've got a list of all the processes running in that VM, and I can actually filter the processes and say OpenSCAD, and now I could attach to that. But actually, before I do, I forgot, I should open the folder. So I actually have the OpenSCAD sources here locally on my Windows machine, but I have not configured anything about this. It's just the code from GitHub. So I don't need to configure my build environment. I'm not going to try and build here. I just want my sources so that I can step through the source. And this is a big code base. So Visual Studio is opening this up. We're actually going to get an error message here about Cmake in a second because there are Cmakeliststxt files in this project, but since it's Cmake, Visual Studio can't actually generate the cache for this because there's extra information it doesn't understand. So that's okay though because we don't want to try and build it. So if I come back to the attach to process dialog, and we're all still set up there, and now I can click attach, and I can say I want to use native GDB. And so now it's opening that up and initializing the debugger. And so now I'm actually attached to that process running on the Linux machine. And we'll see if it works from this side. So if I click that, boom, now I hit that breakpoint. So I can actually set breakpoints. So I had a breakpoint set in this source code beforehand. So now I can actually step through code with attached to process running on this remote system. And once I find the issue that I was looking for, I can come back. I can come back to Visual Studio and I can say, oh, I got it figured out. I'm done, and I can stop debugging. And when I stop debugging, my program over here is not perturbed. Like this is actually all still running. So I can actually attach to that process and start stepping through this code. So that's pretty great. So let's go back and let's close this. And let's come back to the slides for a bit. I lost PowerPoint. Oh, that's good. Oh. I don't know if anybody else saw that. It looks like I have some different. Oh no, it's different. Oh, on my screen that's transparent. That's interesting. So let's open that back up. And let's see where we left off. All right. All right, so some of the things we just took a look at. All right, so some of the things we saw, with just a little bit of setup, you can enable VS Code to talk to a remote environment. And the C++, this is interesting. When you connect to a remote environment, I didn't show this because the demo was already configured. When you connect to a remote environment, that VS Code instance that's running on the remote has its own set of extensions. So you actually install extensions per the remote host that you're talking to. So one remote host might have the C++ extension installed, another might have the .NET or the TypeScript extensions. That is something, as you set up new systems, you have to keep installing the extensions you're using there. And then for the Visual Studio Code demo that we used there, we saw that we're starting to try and improve the productivity a lot more by making it a lot easier to get started, especially for newer people, which isn't the people in this room, but for students in particular to get started. We're really trying to make it a lot easier to use. And of course, VS Code runs across all the major operating systems for Linux, Mac, and Windows. And so in terms of what we've been working on in the Visual Studio Code, and the extension, some of the newer features we've introduced recently are things I showed, like the document comments on hover. There's some other things that we've been doing, the build and debug of the active file. But there's a bunch of other stuff we've been working on to improve IntelliSense performance. The configuration settings editor is fairly new. And the documentation for that editor. Now, I already showed this demo, as I popped over to that. So the OpenSCAD demo, we saw that there's a lot of different ways that people approach cross-platform development, and MXE is certainly a unique way that predates a lot of the technologies we have today, because that MinGW-based environment is a lot older, and it's very suitable if you're trying to compile for Windows on Linux. But you can still work with people across operating systems using LiveShare. And I showed a little bit of WSL. And WSL is just fantastic if you're trying to do Linuxy things from Windows. apt-get works there. It's really great. And so with that, actually, let's take another look at WSL. WSL, the way that Visual Studio, we've worked with WSL as a remote Linux system for a long time now. But the way that has traditionally worked is we made you install SSH in WSL. Which is kind of weird because it's on your local machine. So why am I having to use SSH to talk to something that's on my local machine? On a VM, I understand why. With WSL, why do I have to do this? Well, part of the reason was when WSL started, WSL really wanted to be treated as any other Linux system. And so we kind of said, okay, we won't try and do anything special. We'll just treat you as just another Linux system. But there are tools within Windows so that you can drive WSL via scripting or APIs. And so what we've done recently in Visual Studio is we've added native support for WSL. So you don't need to do that connection anymore. So let's take a quick look. Oh, I did it again. Oh, that's why it went away, because I closed it. I'm not a good PowerPoint person. So what I want to do with Visual Studio, this is the new VS Dialog in 2019. And what I want to do is I want to create a new project. So you can see the list here of all of the projects I've been using recently. You can open a local folder, so we let you just open a folder of code now. This works for C++. For Cmake, we'll configure it as a Cmake project if there's a Cmakeliststxt in there. If it's C++ code that uses some other build system, you can manually configure it with some of the settings files that we have. You can start by just cloning code directly from this dialog, or you can get back to the more traditional thing of just creating a project. And so what I want to show is, oh, there it is. So I've used it before, but so the Cmake project shows up there. So we have this little simple thing for a Cmake project. And so I can just say, create me a Cmake project. And so that is just, so instead of using a Visual Studio project with our project files, this is using Cmakeliststxt. And so if I come in here, this is just a simple little hello world program. So instead of saying hello Cmake, we can say hello Milan. And you can see up here what Visual Studio is doing is Visual Studio is actually generating the Cmake cache. So Visual Studio is reading the Cmakelist.txt's and it's doing the Cmake cache generation so that it can use the IntelliSense from that cache. And so down there at the bottom, you can see all of the spews about that it's going out and it's trying to find the compilers and things. While that's working, I want to show you the Cmakelist.txt file because there's something else going on that's new here. Notice when I hover over add subdirectory, we actually have in-context help for the Cmakelist.txt in Visual Studio now. And if we have also some simple completion as well. So this starts to help you with your Cmakelist.txt, remember what it is that you actually need what are the Cmake commands that you can use for your project. So we're starting to integrate that into Visual Studio here. So that's pretty great. And let's come back over here. We'll set a breakpoint. And what I want to do is here, so this is already configured for x64 debug by default, so this will just run on Windows. But if I want to use that WSL, what I can do is I can drop that down, and there's this Manage Configurations option here. And so what that's going to do, it's going to create a Cmake settings.json file. The Cmake settings.json file is Visual Studio's file for how it drives Cmake. So this is how you can pass options to Cmake and how you can configure it for different environments. And this is the default environment for Windows. But if I click here on the Add Configuration, in this dialog, this is also new. This is a JSON file, so it's just a simple text JSON file. But we've actually added a visual editor for this now. And so if I click that, you'll see that there's a whole bunch of kind of canned options. Because depending on what sort of thing you want to target with Cmake, there's a bunch of different settings that apply to different environments. And so while this list is going to keep getting longer, and hopefully we'll finally do something to make it easier to search this list, but what you can do is you can come in here and you can pick WSL debug and select that one. And then now I can switch back and forth between these two environments. And I can target WSL for a Linux environment, or I could target x64. So I can come in here, and now I have that new option for WSL debug there. And I can choose that option. And now, if I drop this down, it's not ready yet. Sorry, it's generating the cache. So what's different is I don't have SSH configured in my WSL environment. I didn't have to start a process. I didn't have to install an SSH, open SSH. It's using Windows commands to talk to WSL and use WSL directly. So when we detect that WSL is there, we can just call those commands and use it directly. And you can actually see here that so the build files have been written to, this is WSL's nomenclature. To access the Windows side of your world, it's under Mount C and then your Windows path as is there. So that's how that all works. And now we can actually select a target. So this target is coming from Cmake, is where that target's coming from. So I can select that target. And then let me give you one other thing about targets. So this view here in the Solution Explorer is a folder view of the folder of just all the files that are there. But there's this other little window here that says Switch Views. And so if I choose Switch Views, and I can go to Cmake Targets View, and when I choose that, then I can actually see what Cmake is specified as the target. So Cmake has a bunch of libraries specified that it's building and executables that it's building. All of those targets would be listed there. And that gives me an alternate way to look at my source code as opposed to just the flat file list of the folder. But so now I can go ahead and click that. And so now it's actually doing the build instead of just the cache generation. And there we go. So there's our breakpoint. So we've been able to hit that pretty quickly. So yeah, so that's pretty great. And if we look down here, You can see also in the debug output, you can see that those are Linux symbols that are being loaded, not Windows symbols. And so that's using WSL. So that's pretty cool. So that gets you a lot quicker way to start trying to mess around with Linux and GCC than having to set up a full VM or lose all the memory of your host system to your VM so that it can actually perform well. And let's go back to PowerPoint. And this is what I was worried about. I'm not sure I'm going to be able to squeeze in any more demos, but we'll see. So let's pop back down. All right, that's where we were. All right. Let's just maybe not go into the presentation mode. So we took a look at that demo. So yeah, so if you're doing cross-platform development, Cmake is really the way to go. Actually, how many people here are using Cmake? Okay, a good number. Yeah, this is what we're seeing. This is what we're seeing too in the community, is that Cmake is really where the C++ community seems to be going. And so this is the C++ team at Microsoft for the support that we're doing in Visual Studio and what we're looking at for VS Code, that we're increasingly emphasizing Cmake because Cmake is, the community is adopting it, and we're trying to make our support for Cmake better and better. But you can target both Windows and Linux from Visual Studio, and you can actually target the Windows subsystem for Linux now as well. And that SSH connection to your remote Linux systems is great, especially for your larger projects. And one thing I'll say about that attached to process scenario in particular, one of the challenges with the attached to process scenario is if you've got an issue you're trying to debug during startup, and if you're trying to catch a startup issue. If you're trying to catch startup issues with our attached to process experience and you're having difficulties, please reach out to us, because we'd really like to try and improve that scenario in particular, but it is difficult. So let's talk a little bit about Visual Studio, and I'm just going to kind of breeze through this quickly. I don't think I'm going to have time for any more demos because I want to leave at least a little bit of time for questions. So VS 2019 is now available. You can actually, VS is now making it a lot easier to install side by side without risk. So you can install the preview, the previous version side by side, and you're not going to perturb your local environment. So we're really trying to make it as easy as possible to do this. We're also making it possible so that you can use your preferred MSVC toolset with 2019. You can see there that in the options, we're installing by default the current MSVC toolset for 142, but you can actually install the 141 or the 140 toolset as well. You don't need to install the old version of Visual Studio just to get the toolset. You can install the new one and install the toolset. The other thing we're working on is to maintain binary compatibility, because we'd seen that it was very difficult for people to upgrade, not because of necessarily even the side-by-side issues, but they were in a situation where they didn't have binary compat with third-party binaries, and so that was forcing people to stay on an older version of MSVC. So starting around 2015, we've really tried to maintain binary compatibility, and to date through 2019 we've maintained that compatibility, so you should be able to mix and match with older versions of binaries produced by older tool sets. And then let's see, yeah, and then so of course VC package. So VC package, you just clone the VC package repository, and then you run a bootstrapping script on Linux, on Mac, on Windows. They're all provided, and you can run an integrate install, and then you can start searching and installing libraries from VC package. So that makes that very easy. And if you want to check out new features, 16.2 Preview 2 is available now. I know this is we're moving fairly fast with Visual Studio today because we're still in the first half of 2019, and we're already on our second, we've shipped 2 different RTW versions, release versions of Visual Studio. 16.1 for 2019 is the current release version, and 16.2 is available now with the second preview. So we're shipping previews almost monthly, I think, and the release versions roughly every 3 months. The release versions have a quality bar. We do not ship a release version based on time. We ship a release version because it's at the quality level that it's a release version. So we don't try and force that. with that, I think I'm probably going to have to call time. So let me pop down a little bit and skip over some of this. So this is kind of some of our viewpoints on this stuff for cross-platform development. So if you're on Windows and you're targeting Windows, we believe that Visual Studio is the best environment that you can use on Windows for developing targeting Windows. And you can use Cmake or you can use MS-Build or MS-Build. We think that on Windows, MSVC is the best compiler to build binaries for Windows. So we highly encourage you that if you can, use MSVC for producing Windows binaries. And then, if you're on Windows and you're targeting Windows and Linux, still Visual Studio, you can use WSL or the Connection Manager. We've also added, I kind of had to skip over stuff, we've added Clang support into Visual Studio. You can install Clang as part of your Visual Studio install, or you can bring your own version of Clang and point Visual Studio at it. And then, of course, on Linux or Mac, you can use VS Code, VC Package, etc. And so this is a good way to keep up with our team, is the CPP blog is a good way to keep up with us on the dev blogs at Microsoft.com. And questions? Yes? Yes.
What's the feature if you want to be able to work for different CPU architecture?
Okay. So the question was targeting different hosts, but what about targeting different CPU architectures?
Mostly when you can't build code on the target architecture.
When you can't build code on the target architecture. This is something I think we could do more to invest in. And this is one of the reasons why I was asking, if you're an embedded developer, find me and come talk to me, because I want to make embedded development in Visual Studio and VS Code easier. I mentioned I work on the Azure Sphere stuff. The Azure Sphere stuff is exactly that scenario. Azure Sphere is a microcontroller that only has 4 megs of RAM. You can't build your code there. So we have cross compilers that we run on Windows that we then build the Linux-based binaries that run on that architecture. But you can manually configure cross compilers, like you can manually, this is mostly for microcontrollers in my view. It starts to become an issue with things like larger systems like Raspberry Pi, because Raspberry Pi in particular, it's not as beefy as your desktop machine is. It's a scenario we're interested in, but we haven't done a whole lot on that particular scenario. It's an area that we could improve on. You can configure it. But the challenge with the Raspberry Pi in particular is finding the right cross compilers to set up and getting your sysroots set up. So we haven't done anything to optimize that scenario. But you can set it up using the configuration files in VS. Other questions? Yes?
Show an example with the include path integration.
Yes.
Does it integrate with the system, or was it just IntelliSense to find information?
So the question's how do we integrate with the include paths for the remote system to find where they are? Basically, when we make the connection to the remote system for the first time, we inquire from the compiler, and the compiler tells us about the include paths that it's aware of. And then so we build that list based on what the compiler is aware of, and then we synchronize those files over to Windows using rsync. We actually have a Windows version of rsync in Visual Studio that we use to synchronize across Windows and Linux. And then additionally, VC Package, there's a VC Package integrate install, which puts VC Package in a known global location. And so so the compiler doesn't necessarily know about that location, but we know about that location. So we inquire for it and then go call it. Yes?
Okay. Does it work also in the remote debugging actually process in the other direction? I mean, from an Linux machine, I want to debug a Windows running.
So the question is does debugging across platforms work in the other direction? If I'm on a Linux machine, can I connect to a Windows machine and debug binaries on Windows? I don't know. I have not tried that scenario. That's interesting. Yeah, now I've got homework. I don't know. I have not tried that. I think it might work, but I don't know. I haven't tried it. I know what I'm doing tonight in my hotel room. So, thank you. Do we have time for one more?
1 minute.
1 minute, so last question. Anybody? No? Not even a softball? Come on. Okay, well, thank you for your time.